Good morning, grade nines. So I'm just going to go over solving equations using graphs. So this handout should be pretty self-explanatory. It shouldn't be too difficult to do on your own. But I just want to go over just the parts that I think you might have a bit of difficulty with. So it's just, this file saved under PDF, and I believe I put a link here to Desmos. If you can't find it for whatever reason, you can also type in Desmos on your just whatever browser you have there, and then it'll come up and it'll be the graphing calculator there. So when you click on this, I just realized that this link was automatically, I think, included within the handout. So it might be, you'd probably want this to open up in a different tab. So if you don't know how to do that, if you right click on a link, it'll give you different options. So you want to click open link in a new tab. You might want to do that just so then you don't have, you know, one screen where you have to kind of switch back and forth. You're gonna have to, it's just gonna be more confusing. I would click it, I would open this as a new tab. So just right click and click open in a new tab, and then you're good, okay? So what we're doing in this lesson is we're just kind of learning about, we are gonna get to actually solving these equations algebraically, but today we're gonna look at how to solve this using a graph. So what we do in this case is we simply have our equation. So we have 3 over 4x minus 3 is equal to 7. We're going to split this up into two separate equations. We're essentially trying to say in this case that this is our first line, and we actually know how to deal with this. This is just a straight line. We recognize this as a linear equation because it has the form y is equal to mx plus b, right? This is our slope, and this is our y-intercept. So hopefully that makes sense so far. That should be pretty easy, right? So what we're essentially doing is we're trying to figure out, when does this line equal 7, right? That's really what we're trying to do when we solve graphically. So instead of us solving it algebraically, what we're going to do is we're going to find out what these two lines look like, and then we're going to try to find out where they intersect. That's really our goal, is find out where these two lines will merge and meet each other. So we're going to graph out the two separate equations. So here's our first equation. And then our second equation, I'm going to just write over here, is y is equal to 7. So you're going to graph both of them out. So I'm going to show you how you graph them out. So you go to Desmos, and I know I have all these instructions on the handout there, but I figured I should just start from scratch here. So I'm going to have y is equal to 3 over 4x. Oops. And when you type this in, you're going to have to move your cursor to the right just one time like this. So if you see here, if I type in, so to get the equation, I'm typing in 3/4. When I put this little slash, this symbol right here, oops, hold on, it's not working there. That symbol right there, it automatically makes a fraction for me, but then I want to stop it from creating variables in the denominator, right? So if I want to if I start typing in the x, it's actually going to create a totally separate equation. I want to move the cursor just one time, and then it automatically goes back to the main line there. And then I write 3 over 4x minus 3. So there's my line. I'm just going to clear this so you can see it more, a little better. And then my next line that I'm going to graph is y is equal to 7. And once I have this, if you want to switch the way the graph looks, sometimes I find I don't like the way the default graph looks like. You can always switch that. So you just get rid of the minor grid lines, and then you're just going to type in 1 here, and type in 1 there. And that just means that you're going up by 1. And then, of course, you can zoom in a little bit, right? If it makes it a little more clear. That's just my preference. I don't know if some people are not as picky about it, but I just personally like it when it's a bit more clear. So now the line, now the whole problem is a bit more clear to me, right? So again, to solve this equation, what my goal is to find out when the left side of the equation is equal to the right side of the equation, which is 7. So I really just drew out the two graphs, and all I'm trying to figure out is, where do these two lines merge? The nice thing about Desmos is a lot of the work is actually done for you. You could, of course, approximate it. I think most of you can kind of visualize where they meet. You would draw a little dash there. Oops, actually, I already did it for me. You draw a dash line going down here, and then you can actually tell yourself that they meet at approximately 13 and a third, right? Somewhere in between. And if I want to verify that with decimals, the great thing about this is all I have to do is click on the point near the point. As long as you click pretty close to the point or exactly on it, where they intersect, it'll give you the exact solution. It's 13.333 for the x coordinate, and the y coordinate is 7. And that makes sense that it's 7 for the y coordinate because we want this equation to equal 7. So going back to the handout, again, this should be pretty easy to follow because it gives a lot of the instructions on there. What we notice is that the point of intersection is 13.333 and 7. So when I ask you to write in the point of intersection, all I'm going to do is simply write 13.333 and 7. And for the next part, it says the x coordinate of the point is a solution to the equation. Oops, and for some reason it's not keeping it on there. Sorry, my apologies. Let me just fix that up. It's probably going to be easier if I use this one here. So it's going to be 13.333 and 7. And of course, the solution to the equation is the x coordinate. So that means that my solution would be x is equal to 13.333. And this would be the solution to the equation. So how does this actually work? So this is when we get to the algebra part. And again, we are going to learn how to solve equations algebraically. That's actually our next lesson. But for this lesson, we're just kind of focused on using graphs to help us solve it. But once we have the solution, how do we check if it's correct? That's actually pretty easy. And we have already covered that before, but I'll go over it again. So what we do is we take our solution, which is 13.333, and I simply will sub it back into my equation. So I already did this for you, but I'm going to do it from scratch so you can see exactly how I did this. So what you're going to do is you are simply going to, oops, let me erase that. You are going to sub in 13.333 into your x value. So we have y is equal to 3 over 4 times 13.333, which actually it probably would be better if I wrote it as a fraction. I would get an exact answer there. So then you have y is equal to 3 over 4 times 13.333. If you take 3 over 4 times 13.333, you will get approximately 9.99999, which actually really means that it's 10, really, because this is actually a fraction itself. But let's just say, I don't want to confuse you too much. That's why I decided just to keep it as a decimal. Let's say it's going to be 9.99999, which really we could treat as if it was 10, right? Because it almost is 10 there. And then we end up finding that this would be approximately 7. It's obviously rounded, and that's why the answer was slightly off. But then that should make sense that our y coordinate would be 7 because we know that the left side should equal the right side. So I can see here clearly this is the solution. 13.333 is the x value that would make the whole entire equation equal to 7, which is what we wanted to do from the beginning. Because really, that was our initial question, was what value of x, what number do I have to sub into x so that when what number do I sub into x so that the left side equals the right side here, which is equal to 7. And I already solved that. And I can easily see here that the number I would have to multiply 3 over 4 by minus 3 to give me to give me 7 is 13.333. Okay, so that was one way that we can solve an equation graphically. Like I said, algebraically, we'll leave that for today, for later on in the second lesson. But how do you do this with table values? So with the table values, you essentially are just playing a guessing game. We call that guessing and checking in math. So guess and check, where you try different numbers and then you see which numbers work. So what I'm going to do is I'm actually going to create a table of values, and it's just a horizontal table of values instead of a vertical one, but I hope it doesn't throw you off. It works the exact same way. So what we're going to do is we're going to sub in different values of x into this equation. Now, why did I pick 0, 1, 2, 3, 4, 5? Because they're easy numbers, right? No other rationale other than that. Ideally, if you are doing a table of values, you want to be strategic about this. You want to pick numbers that work the best with it, right? So before you even start, you probably should have kind of an idea of what numbers you should sub in. And just a little warning on some of the homework questions, they ask you to solve using a table of values. And there are going to be a few of them where it might not be that clear what numbers you should sub in. But just like I said, just try different numbers. The best strategy I can tell you is pick a couple points that would make the most sense to you, right? Sometimes they might be negatives, but in this case, I'm just looking at the equation itself, I just had a good feeling that it wasn't going to be that a negative number wouldn't necessarily work, but you may have to also include some negative numbers as well. So I just randomly picked, whole numbers. They just made the most sense to me here. Sorry. So now what we're going to do is we're simply going to sub in all the x values here. So let's just do the work down here. So we have 4 times 0 minus 3. We know that that ends up giving us -3. So that's -3. And then here we have 4 times 1 minus 3. That gives us 4 times 1, which is 4, minus 3 is 1. And then I have 4 times 2 minus 3. And we know 4 times 2 is 8, minus 3 is 5. And then I have, but I'm really running out of space. That's okay. So I'm going to have to go underneath. 4 times 3 minus 3. And we know 4 times 3 is 12, minus 3 is 9. So I could fill this in, but I think some of you have already started to notice a bit of a pattern. You said, do I really have to solve it when I know that it's just increasing by 4 each time? You can definitely use that trick, right? It's increasing by 4 each time. So I could do the work here, but I think you're starting to see what the value should be. It should be 13. And the next one, if I add 4 again, it should be 17. But I'm going to go underneath and show the work just so everyone's clear on it. So for 4, when x is equal to 4, I'm going to take 4 times 4 minus 3, which gives me 13. And when x is equal to 5, I'm going to take 4 times 5, which is 20, minus 3, which is 17 altogether. Okay, so how can I use the table of values to help me estimate the answer? Well, what did the question ask us to do? The question asked us to find the value of x that would, and I'm just going to switch the color here so you can see it. The question asks us to find the value of x so that when we sub it into our equation on the left-hand side here, we end up getting 15. So which of these values is the closest to 15 so far from what we've seen? Well, just looking at these values, I can tell you right now, the one, it's 15 seems to be somewhere in between the x is equal to 4 and x is equal to 5. So if I were to approximate this, if you were trying to guess what the answer would be, what would you say it is? Well, it's between 4 and 5. So what's a good estimate here? So a good estimate, I think most of you can probably try to see, it's right in between 4 and 5. So I would say x is equal to 4.5 would be our best estimate. So I would say x is equal to 4.5 is our best answer. And then how can you check if it's a good answer? Well, you can sub it into your equation and we can see how close we are. So we have 4 times 4.5 minus 3 is equal to 15. So now let's do the math here. 4 times 4.5, what's 4 times 4.5? So that would end up giving us 18. I'm just going to continue on this side here because I'm running out of space. 18 minus 3, which is equal to 15. And I can clearly see that this is true, right? 18 minus 3 is 15, and that definitely is equal to the right-hand side. So this is correct. So how do we use graphing technology to prove that this is correct? So what we're going to do is we're going to go back to Desmos, and we're going to simply, so I'm going to write out the equation so everyone's clear on what it is. So my equation was 4x minus 3 is equal to 15. So what I'm going to do is I'm going to split up my equation just like I did before. This is my first equation. This is my second equation. And in my first equation, I'm going to write y is equal to 4x minus 3. And sorry, that's in my first equation. And my second equation, I'm going to write y is equal to 15. And then I'm going to simply graph these out. So I type in y is equal to 4x minus 3. And I have to put the y in front. Keep that in mind. The only instance I wouldn't do that is if it's a vertical line, but we're not going to cover that right in this lesson. And then we're going to type in y is equal to 15 in the second line. And now my goal is just to figure out where do these two lines meet. Where the two lines meet, that is my solution right there. And I can see here that these two lines will meet at, and you can't really see that's covered up, 4.5 and 15. So that means that the x value of the point of intersection where they meet is my solution. So x is equal to 4.5. And that is my solution to the equation. So I hope that kind of makes sense. So in conclusion, going back to this, there's, like I said, I just want to kind of clarify all these points before, obviously, I think the majority of the work of this handout you should be able to do on your own. It should be pretty easy. I just want to clarify a couple of those parts here. So just so everyone is clear on what you're doing in this next section here, you're simply going to graph out y is equal to 4x minus 3 on one line. And then on the second line, you're going to graph out y is equal to 17. And then you're just going to find out where the two lines meet. So again, what you're doing here when you're using technology, you graph out y is equal to the left-hand side of the equation and y is equal to the right-hand side of the equation. And then you find the point of intersection. The x-coordinate is the solution. And then if you're using a table of values, you're basically using guess and check, right? You're trying out different values, and then you try to find the best approximation for it. Okay, we will actually get into solving these equations. We haven't done that yet, but that's our next step. All right, that's it for today.